Cool. So thank you for being here. Thank you for listening. I am James. I'm here to tell you about Stork, which is a side project that I've been working on for about 2 years. Um, it's an open source tool for adding interactive full text search interfaces to websites. And the original tagline was actually impossibly fast web search made for the Jamstack. But I didn't go with that. I was trying to write it out. I couldn't figure out whether the first 3 letters of Jamstack should be capitalized or not. So I went with something else, and now the moment has passed. Before I get started, I want to thank Jim and all of the rest of you guys at Jamstack Boston for having me here and letting me talk to you about Stork. But before I want to talk about Stork, I will talk about myself. So I work at Stripe. I'm an iOS engineer, actually, not a web guy professionally, but web has always held a special place in my heart. I'm from Boston. I live in Cambridge now. I have a website. I have a Twitter account. But more importantly, for what I want to tell you about today, I was on the staff of the college newspaper. I did graphic design, ultimately ended up rebuilding the newspaper's website. I'm also obsessed with the web as a document and application platform. The web, I mentioned, holds this special place in my heart, exploring the fuzzy area of using the web to share ideas through documents, through hypertext, and then also building experiences on the web for browsing through those documents. And those two things, my experience in student journalism and my love for the web platform, means that I've thought a lot about search. When I was building this newspaper's website, we needed a search box. It was pretty much seen as an essential feature. It was important for everyone, but especially the editors of this newspaper, to be able to remember some event that happened a long time ago and quickly find the article describing how it happened, when it happened. A newspaper is a historical record for a community, and being able to look through that historical record was very important to us. And we tried lots of different search solutions. None of them were really quite right. Students don't really have money to throw at the problem, so we couldn't use a SaaS like Algolia or something like that. Students don't have time to be system administrators. We couldn't wrangle a lot of servers and build our own search service. And the other thing is, students don't stick around for very long. You get however much time you're in school and then you're out. So if you want to build a complicated system, you either have to have immaculate documentation, or you have to be willing to let it crumble and fall away as people lose context and forget about it. More importantly to me, though, building some sort of complicated server-side search application didn't feel exciting. That's not the kind of website that I want to build. I ended up thinking a lot about the kind of website that I do want to build. We ended up just iframing a Google search thing on this website because there wasn't a really good solution that we could come up with. But as I was doing this thinking about what kind of website I want to build, how could search work on these kinds of websites, Chris Coyier dropped the serverless microsite as part of CSS Tricks. And you know it's a good day when Chris Coyier drops something. So this idea of serverless became the defining framework for how I built websites and how I designed web architectures. And I really felt like it was the best architecture for the web platform, respecting these web platform ideals like progressive enhancements, the whole idea of like cool URIs don't change, that sort of thing. The biggest thing that stood out to me when designing a serverless site is that there are just about 2 opportunities to make computations for whatever that means to you. The first is at build time, and the second is during page load, once your user loads the page and then through AJAX requests afterwards. And usually search just happens in that second half through an API. You post some search query to a search endpoint. That server will churn through a database, maybe reorder the results to make it more relevant to the person who's doing the searching, and then on-demand results come back for every request. But serverless search felt different to me. This is certainly one way of doing it, but I wanted to think about what search means in a more in an architecture that can take advantage of both of these. And so the architecture that I started thinking about is one where you pre-compute search results for every possible query at build time, and then at runtime have some JavaScript that just filters through that data and shows you the results that were computed at build. And it doesn't work if your site is too large, but you know, I'll spoil a little bit of it and tell you that, you know, there aren't a lot of sites don't have indexes that are going to be too large for this kind of thing. These ideas are more common now as serverless sites, Jamstack sites have gotten bigger, proliferated a little bit more, and you're seeing more and more sites with architectures where you have a lot of computation that happens at build time, and then the interactive, personalized stuff is sort of made to appear after the page load. And I think a lot of people call this the island architecture now. Astro, the framework, may have popularized that name. But with the island architecture, you have server rendered React components, and then you hydrate these client React components to have little islands of interactivity. When we think about the island architecture, we mostly think about client-side versus server-side React components, but I sort of think that the idea can be extended, and Stork, for me, is an extension of that idea. And I want to demonstrate what I mean, but let me switch gears just a little bit. Let's talk about images. I want to tell you some things that I know about how images work. When you get an image on a web page, the web browser makes a GET request to a server and gets back a random bag of bytes. And you're not going to be the one to look in that random bag of bytes and say, oh, it's a PNG. You don't need to know what they are. You just need to know that the request happens. The browser knows how to do something special with those bytes. And in this case, that something special is render them, turn it into a canvas of the proper size and make all of the pixels the right color, and display it on the page. And ultimately, it turns into the image that had been generated beforehand. These are relatively large files. They don't have to be super large, but they're relatively large files. So we serve them from a CDN, so we can serve them from the edge and cache them because they don't change. We might do some pre-processing, especially now if you're using source set to make a bunch of images of a bunch of different sizes. If you want to convert your image into a modern format like AVIF, you do all of this pre-processing to make it as easy for the browser to render as possible. And this might be a controversial opinion, so feel free to disagree with me on this one, but I believe that images improve the experience of using the web. And so in summary, when you're loading an image on a web page, you're loading some data from somewhere, some server, and your browser is rendering it using some black box mechanism. You don't need to know how Firefox's ping decoder works, but it turns this bag of bytes into something more exciting. And we can go back to the islands, but now they're not islands, they're not hydrated React components, but they're data passed through a renderer. That data might be the bytes for our ping passing through the browser's ping renderer. They could be like a 3D mesh and a texture and shader data getting passed into a WebGL render context. But so now we're not talking about islands of interactivity. We're talking about entire portals to externally rendered experiences where you have data, you have a renderer that is rendering that data in this special way, and you're creating something that otherwise couldn't be shown just in a text document. And so we have images, but you can also, and 3D models using WebGL, 3.js if you're really fancy. But you can imagine that this can go beyond just like images, 3D scenes. You can imagine a binary file that describes a rich animation. That's sort of a concept that you use a lot in iOS development. Or maybe your data describes how to display some interactive data visualization kind of thing. Or maybe, and this is the idea that I've been thinking about for a while now, your data is a search index, and your renderer takes that search index and renders an interactive search bar. And so I've been building that for a long time now. This is the search solution that I feel like I needed when I was originally building that newspaper's website. I kept on designing it, realizing that the architecture made a ton of sense for sites that aren't too big, sites that don't update too frequently, a lot of these sites that we're building with Jamstack technologies. This feels like a Jamstack native search solution where you have your search index and you have your renderer in the form of a JavaScript library, and it turns into this this portal to this interactive search experience. And so I was thinking about all of this and was designing and building. After about 8 months of building, I had built Stork. And this is the website for the project, storksearch.net. And the idea is sort of one that I have described. You generate a search index based on your content. That index is a bag of arbitrary bytes. You don't really need to care what's in it. And then sort of just like you would for an image, you upload that search index to your web server, to a CDN, and the Stork JavaScript library will download it on page load and then render it and turn sort of any arbitrary input element into a fully interactive full text search experience. And I promise I'll demo it in just a few minutes after we sort of go through how it works. The green area here becomes the portal to the managed experience. It's the interactive part. You don't really need to know what the JavaScript library is doing to make it interactive. And everything else is sort of just a statically generated Next.js site. So I'll get to the demo. I want to show you how you include a Stork search bar on your own site, but I'll stop here if there are any questions, and so I can take a drink of water.
I guess I had a quick question, and maybe you're going to get to this, James. But so it sounds like, Stork is both the kind of build step happening in Rust to build a search index, and also there might be a small JS library that's giving you the front end interactive part. Is that correct?
Yeah.
And so how extensible is that front end experience? Is it like I'm including this bit of JavaScript and then it's going to be like, is every Stork search going to look like a Stork search, or can I kind of customize that experience?
There are themes. You can choose one of, I think, 5 themes right now. They all kind of look the same because I'm no designer. I don't have much of a sense of all of these different independently cool ways the search bar could look. But a theme is just a CSS file, and I sort of encourage you to check out what each CSS file is doing and change whatever styles you want, and you don't even have to use the themes that I give you. You can start from scratch.
Oh, very cool. Thanks.
Yeah. So we can go through a little bit of a contrived demo of how you would create a search index loaded up onto a site. So let's say that we have a folder of pages. This might be my blog or something. The first thing that I would do is create a configuration file that outlines all of the files that I have on disk that I want to index, and then all of the destinations for those files. So all of the URLs that those blog posts will live on after the site is published. This might be what the config file looks like for our blog. And in the terminal, we'll run the build command. That's the binary to create an index, and that'll create a file at blog.st. And it sort of doesn't, that's our binary file, kind of like an image. It doesn't matter what's in it. It is a search index file. And then we'd upload that to our web server. That's our good friend Cyberduck representing our web server somewhere. And then it would be live, and we can look inside of our index.html file to see how we're pulling that file in. There's not much to a Stork integration. This is the input. You need a div to basically give you a landing pad for all of the results. Here's the stork.js file that we're getting from the third-party library. And then we register the search index. And I've accidentally messed up my slides and called it something different here, but that's our search index file. And the Stork JavaScript library is getting the WebAssembly blob. It's getting that that file from the server, and then harnessing the DOM and doing that transformation and making it this interactive experience. And so finally, we'll get to the demo. I'll try to open up this CodePen link, see if it'll come over onto the desktop. And you can see this is sort of the same HTML, and I added a little bit of CSS, and we can search. I think it's searching my blog for through like my blog posts, and so we can search for Stork and see where I've written about Stork on my own blog, and if we want to search for this little phrase about Stork search algorithm, we can do that. And it'll know to bump it up to the top because that's the article that I want to look at. And then, of course, I could click on it, and CodePen would keep me in the iframe, but bump me over to my web page. And that's Stork. And you would include this sort of anywhere you want on your web page. You can, again, theme it, make it look however you want. But ultimately, it should feel relatively simple. Type in something you want to search for, and then get some search results. Let's talk about how it works a little bit, because it's slightly more complex than I think I try to make it look. As we've mentioned, it's mostly written in Rust. It compiles to the command line tool, the binary, and then also a WebAssembly blob that the JavaScript, actually TypeScript shim library will load in and interact with. And I used Rust, I used WebAssembly so that I could share code between the indexer and the indexer module and the search module. And because this happened to be a really good use case for WebAssembly. WebAssembly makes this kind of computation especially fast. And one of the things that I wanted to do with Stork is bring these complicated web technologies to the people who feel like they might not be ready to dive into those APIs on their own. Before I started this, I didn't know much about WebAssembly at all, other than it is a fast way of implementing these more mathematically oriented algorithms. And I wanted people to be able to take advantage of that in various ways without having to know about how to use them. And I felt like this was a good opportunity to do so. So there's this JavaScript shim code layer that you actually interact with on the page. It handles sort of three different things: loading the WebAssembly, loading the index, attaching to the elements to make them interactive. It's Rust and TypeScript, but there are a few other languages as well. This is sort of the diagram of what the JavaScript shim layer is doing. These are three asynchronous processes. Actually, the DOM one never resolves. You always want to keep the DOM harnessed. And so this JavaScript library has to figure out at what point the WebAssembly is loaded, at what point the index is loaded, and then let you type search queries all in here, but only start resolving them after both of those are loaded. That's why the TypeScript bar is, I think, bigger than most people expect, because there's some complexity there. And the WebAssembly part is really just doing the lookup algorithm. And actually, we can talk about what that lookup algorithm is. Let's say that we want to search a search index for this phrase, never gonna give. And I haven't kept the last E on give, because this is how you would type it out. And we want to be able to get results for the phrase, even if we haven't finished typing. So we've got never gonna give. The first thing Stork will do is segment it into different words. And at this point, we can look up things from our lookup table. That is ultimately what the Stork search index is a lookup table based on words that you might query for. And so we have various results in various documents, and each document has an index. This is so the word never is the 25th word, the 38th word, and the 201st word in document 1. And these are all hypothetical examples, but we'll sort of use this to get back to search results. The other interesting thing is that GIV is not a word, but we know that it can alias to give. And so when we're doing our lookup, we'll follow that alias and also include the results for things that are in the word, things that contain the word give. From there, we combine these results. So you'll notice that document 1 has a result at 25, a result at 26, and a result at 27. So we can combine those and make that a range of we know that words 25 through 27 are a match. The same for 201, 202, and 203 in document 1. And then document 5 is an interesting one. The word never is at word 108. The word give is at word 116. Gonna is not in document 5, but those 108 and 116 are close enough that we might still want to display that entire range of words to see if the person is searching for that. So we'll make that a range as well. We'll sort of extend it out, give it a little bit of leeway there. Document 2 seems to not really have many relevant results. We can just include these two words. And now we can look through our documents and find the excerpts of text at these ranges. But before we do that, we'll want to sort to make it so that these results are ordered in a way that the top ones are most relevant to the person searching. So Stork's algorithm assumes that any ranges are probably going to be more important than any singular words on their own. So we put the ranges first, and we put documents with more ranges ahead of documents with fewer ranges. And now we can do what I was saying earlier and resolve all of those to actual quotes from the documents. And it sort of becomes clear that ultimately what we have is a really good match with document 1. It's got 2 instances of our search query right in a row. Document 5 has our 1 result, and it's got our 2 words that are far apart. Maybe that's what you want, but probably not. And then document 2, less relevant results. And that's ultimately how the Stork search algorithm works, how it will return ordered matching results and be able to highlight them the way that the demo sort of showed. Let's talk about what's next for Stork. Mostly so that I can draw a line in the sand and say, here's where we're going, but also because this is sort of a nice demo, and it's nice to sort of be able to hear about what the plan is for the project in the future. So the way that I see the broader term future of Stork is that it should be the obvious choice for search. If you're building a static-ish site, if you're building a Jamstack site, something that isn't too big, doesn't update too often, I still want to put it into this newspaper's website that I built years ago now at this point, because I think it would be a really good use case. It's a WordPress site. It updates about once a week with about 20 new articles every week. I think Stork would be the clear winner today if we were implementing search. For me, I see Stork as a lifetime project, which is an idea that I borrowed or stole from a coworker and person I admire, Johnny Hallman, who works on an app called Cushion. He tweets about his process of working, very like hashtag work in public kind of project. I admire that. He came up with this idea that Cushion is a lifetime project for him, where he might not be working on it as fast as possible, but he's going to continue working on it over time, thoughtfully add features, things like that. I want to skate to where the puck is going in terms of the web platform. One of the things that I had said is that Stork allowed me to bring WebAssembly to people who hadn't necessarily had experience with WebAssembly or didn't want to learn about all of the ways that WebAssembly can mess up. And I sort of want to do this for more web technologies too. I want to make it very easy for people using new web tech to integrate with Stork. And I want people who want to use new web tech to get that from Stork. Ultimately, I've written up some broader thoughts on the slash roadmap page of the project. And I sort of believe that any good open source project should talk about where it wants to go so that contributors can contribute in that direction, to hold the creator maintainer responsible for that. I believe that it's an important thing for open source projects to have, so I've written up one for myself. More shorter term, I have a lot of things that I want to do with Stork. You can see this is sort of, I've got lots of pages in lots of different notebooks, like here are all of the things that I want to build with Stork. And it's definitely the case that I have more features than I have time. But the ones that I'm sort of thinking about most urgently are adding web worker support for one. Having those searches compute in the background would do a lot for page responsiveness, especially if you have really large indexes. I'm interested in building React bindings. A lot of these new static site generators built with React, people have been asking, and I've been trying to think about how to make a React front end. So you add a component instead of pulling in a JavaScript library and calling some functions. I sort of mentioned this a little bit before, but better integration with the web tools that people are using today. So more static site generators, more publishing platforms, things like that. I want people, like if you're using any sort of publishing platform, there should be an easy on-ramp to Stork. One of the things that I've been thinking about is how to turn this into a SaaS, software as a service. And if people were interested in uploading documents to a web dashboard and then having Stork infrastructure host the search index and re-update it everywhere, that's something that I've been considering. But today is sort of the first day that I am announcing that I'm now selling stickers of the little Stork mascot, who I've affectionately named Sylvester. So if you go to /sticker on the web page, you'll end up on a Stripe payment link where you can buy a sticker, and I will mail it out and send it to you. So that's Stork. That's sort of what I've been working on, what I wanted to talk to you about. Again, thank you so much for coming and letting me talk to you about it and letting me share. And I'm happy to take questions, happy to, I don't know, talk about more of the ideas that I have about Jamstack and interactivity and things like that. But I'm going to close down the slide so I can go back to the video chat and see everyone's faces.
Thanks so much for sharing, James. That was really awesome. I can tell how much work you've put into this project. It's far more complicated than I would think at first, glance. I have several questions. Sometimes, people are a little shy to ask the first question. So I'll ask a couple and then I'll turn over to other folks. If
yeah, go for it.
So when you're doing your CodePen example there, I assume that, so you're referencing out to a personal site. So my assumption is that personal site has Stork built into that build process in order to provide that index that it needs in order for the project to work. Is that correct?
Yeah, exactly. So the build process is run an 11D. It's an 11D site. So it'll run that, and then wget the Stork binary from Netlify's build servers, run Stork over the generated site, and then stick a search index in where the rest of the site expects it to be.
Awesome. And then also, yeah, and it also looks like you're kind of parsing HTML documents. So basically this would work with any static site generator. After the build, you go and then you digest that information. Okay, that's really cool.
Yeah,
Can
so it
you, I
works
mean,
with plain text. If you have a bunch of plain text files for some reason, it works with HTML. It works for Markdown. And one of the original use cases that I saw this for was searching through a bunch of subtitles for videos. And so one of the lesser known Stork features is that you can feed it a bunch of subtitle files. And then when you're searching it and click on a search result, it will link to that timestamp of the video. There's a page on the website where I think I have that implemented for a bunch of math lectures. You can search for second derivative and click on it, and it'll go right to the place where they're talking about second derivatives in the lecture.
nice. That's really cool. And then when you're kind of demoing like a little snippet, you had a TOML configuration file for your Stork index building. Now, how complicated is it to set something up like that? So is there, like, can wildcards be used or anything? Or are you actually going through and mapping kind of node by node? Because it looked like you're mapping, an HTML file to like a URL endpoint. What does that process look like to set it up? Is it a lot of manual work?
It depends on, I think it's manual work in the sense of every build system will be different. This is sort of where I hope to make more on-ramps and have like a Netlify or an 11D plugin that will go through all of the generated HTML pages. But yeah, there's no sort of automatic Stork wildcard pointed at a directory just yet. I think it's like issue number 8 in the project, something that I know is a gap, I guess.
Sure. Cool. I'll ask one more and then I'll give other folks a second to ask them. So yeah, that was really cool when you're explaining how you're kind of building that index and how those numbers correspond to other content. That stuff seems super complicated. Kudos for figuring that out. And thank you for sharing it with us as an open source project. That's really cool of you. Is that this is someone not knowing much about search. So are you doing that process mainly to kind of save from having to load a ton of content all at one time and you're loading a smaller amount, or is it making it easier for you to actually rank results because you're doing some cool things with like how you're deciding what order to put in? So that stuff is really interesting. What's like the main process of doing it? Is that just how search has to be in general? I don't know.
Search is made up of 2 main processes. The first is finding your list of matches. And that is sort of the first part where you're looking at all of the words and saying, where do these words appear in all of the text? After that, just as important, if not more, is ordering those results. So you want your most relevant results to be at the top of your list, your least relevant results to be at the bottom. People expect that of search, and I think they would not be happy with the results if it was ordered in like published date or something like that. And so a lot of the process that I go through is trying to figure out semi-heuristically, what are you most likely to be looking for? How are these words present in all of the documents? And surfacing the ones where the words as present in the document are most similar to the way that you searched for them, if that makes sense.
Yep. Great. Thanks. Do other folks have questions? Jeff?
Thanks, James. This is very interesting. I'm new to the Jamstack, so this is probably very naive questions. But I was wondering, do you have any support for auto-completion or plans to add it?
It certainly plans to add it, yeah.
What's the challenges there? Supporting autocomplete in like mid-sentence, or what? I'm curious what kind of challenges you'd have to deal with.
I think it's less that challenges and more just this is a nights and weekends project and I haven't gotten to it yet. The way Stork works right now, we saw with the give example, you can get from partial word to full word fairly easily. It would just be a separate process to display that in a certain way in the search box, for example. But I think right now there is some sort of support for like type ahead a little bit. So if you are searching for GIV, it will return all of the results that match the full word give.
Okay.
And highlight it as if you searched for the full word give.
Right. Okay. Thanks.
else? Any other thoughts or questions? Or
I have a couple more. So if someone thinks of one after this, they can go.
Yeah.
So I'm curious. Obviously, you have this set up to kind of work with a build process, 11D, things like that. Could Stork be used with another framework, like something like a CMS or an MVC framework, where pages are being built on the fly? And what would that look like? Is that possible?
Pages being built on the fly, maybe. There would have to be some process. I think so. It depends on the build process. I think this is where it gets very like situation specific. I can imagine a program that exports a snapshot of the CMS and creates a configuration file based on that. You can inline content into a configuration file if you want. And every hour or every half hour or something like that creates a new search index based on the most up-to-date CMS contents. I think for more, I'm not sure how dynamic you're thinking about, but I think too dynamic, it might fall apart or might not. The way that Stork wants to think about content might not match up with the way that your application thinks about content.
Sure. Yeah, and this is just curiosity. I'm not suggesting. I mean, it makes sense to like try to do something very well versus trying to do everything kind of okay.
Yeah.
So I was just curious if
one of the original things that I was poking with, because this newspaper website that was the narrative through line of the talk was a WordPress site. And originally I was like, oh, I'll build a WordPress plugin. Every time an article is published, it will regenerate the index and republish the site. And that never materialized, but would still be super cool if it existed.
Yeah. Nice. And then I guess, have you thought about the competitive landscape at all? Are there other open source projects doing similar things? One that comes to my mind, and I haven't actually used this, but I think it's Mealy Search or Melly Search.
Melly Search is really cool. Yeah. There are a bunch out there. Like I know Tiny Search is one, Puny Search might be another. Older versions of the same sort of idea are things like Lunar.js or Solar.js. I think this is an idea that, you know, as it just so happened, I found out about all of these other implementations of the same thing after I had built mine.
Of course, yeah.
But it is cool to see all of these different ways of poking at the same idea. And, you know, some of these have different business plans and work better with different things. And I think it's cool that they can all exist in the same landscape for sure.
Yeah. And it's so interesting, you know, on the surface, you hear something that's like, okay, they're Rust-based search engines that can work with the Jamstack. It's like the same thing, right? But if you're into that world, you'll notice that they're not implemented the same way, and there are nuances. And for people who spend a lot of time with this stuff, those differences are huge. They seem like enormous. So yeah, it's cool. It's cool that you're thinking about how you kind of fit in with that ecosystem. And it's cool that you're aware of those other projects too.
For sure.
My last question here is, who designed your mascot? I really like it. I'm going to
go. Oh, it's awesome. So I have talked about Stork in a few other places. One of those was with Fission.codes, which is a startup. And they, at the time, I talked about my roadmap page, and one of the last thing on the roadmap was like, oh, figure out how to get a logo, because that certainly wasn't something that I had any experience in. And the Fission organizer pointed me towards a guy named Bruno Montz, who had done their logo and had made logos for a few different projects of theirs, and sort of introduced us on Twitter. And Bruno, I had an idea of what I wanted the logo to look like, and I sort of bumbled around my explanation to him, and he nailed it. He knocked it out of the park.
Nice.
That's exactly what I was thinking, and I'm really excited that the stickers exist now.
Yeah, that's so cool. I heard somewhere, I think it was said in jest, but there might be some truth to it, but like open source projects with logos or mascots do way better than ones that don't have them. So congrats on getting that.
And it certainly didn't feel like a real thing that I was working on until I got the logo. It was just like, oh, this is a GitHub repository that I'm just poking at. And then once it had the logo, now it's a real project with real goals and things like that.
Yeah. It like kind of brings it to life, right?
Exactly.
Yeah, it's cool. Anyone else have questions for James? Okay. All right. Thanks so much. That was awesome.
Thank you
I'm
for
really
having
excited about the
me.
project.